Ohm's law. By the end of this lesson, you should be able to describe the relationship between state Ohm's law, define resistance, in a water circuit, the pump forces water through the pipes. Compare the flow rate of water through the pipes. Which pipe has a faster flow rate of water? The flow rate of water is much faster in the wider pipe. If the pipes are narrow, the pump has to do more work than if the pipes are wide. Narrow pipes resist the flow of water much more than the wide pipes do. Increase the pressure of the pump by clicking on the pump. What happens to the flow rate of water? As the pressure of the pump increases, the flow rate of water increases. Hence, the flow rate depends on the pressure from the pump and the resistance of the pipes. Observe the circuits. Why are the readings of the ammeters different? What are the factors that affect the flow of current in a circuit? In an electric circuit, the current depends on the battery voltage and the components in the circuit. The figure shows an investigation of the relationship between current and voltage for different components. When the switch is switched on, record the ammeter and the voltmeter readings. Use the rheostat to vary the current value. For each new setting of the rheostat, measure the current and the voltage. The measurements can be plotted on a graph of voltage against current. From the slope of the graph, the resistance of the conductor can be determined. The resistance R of a conductor is defined as the ratio of the voltage V across the material to the flowing current I. The unit of resistance is the ohm. R equals V over I, where V equals potential difference or voltage in volts, I equals current in amperes, and R equals resistant in ohms. The circuit is connected to investigate the relationship between the current I and the potential difference V across a wire conductor. The graph of voltage against current in Figure 2 will be plotted once the switch is switched on. Click on the switch to see the result. From the graph, how is potential difference V related to current I? The graph is a straight line through the origin. Hence, the potential difference is directly proportional to current, that is, V is directly proportional to I. This relationship is known as the Ohm's law. Ohm's law states that for a wire, when the temperature remains the same, potential difference divided by the current is a constant. The wire is said to be an ohmic conductor. Ohmic conductors obey the Ohm's law. Ohmic conductors have resistance which does not depend on current. An example of an ohmic conductor is a metallic wire. From the graph, what can you say about the value of the slope? What is the physical quantity represented by the slope of the graph of voltage V against current I? The slope of the graph equals delta V over delta I equals constant value. The resistance R of a conductor is defined by the equation R equals V over I. Hence, the slope represents the resistance of the wire. R equals delta V over delta I equals 2.0 ohm. In this case, the resistance of the wire is 2 ohm. The circuit is connected to investigate the relationship between the current I and the potential difference V across a light bulb. The graph of voltage against current in Figure 2 will be plotted once the switch is switched on. Click on the switch to see the result. The graph of V versus I for a light bulb is a curve. What is represented by the slope of the graph? Why does the slope become steeper as the current increases? The slope represents the resistance R. Hence, the increasing slope means that the light bulb has more resistance as the current increases. As the current increases, the light becomes brighter due to the rise in temperature of the filament. Thus, the filament resistance increases with increased temperature. Any conductor with a resistance that changes with current is a non-ohmic conductor. Non-ohmic conductors do not obey the Ohm's law. An example of a non-ohmic conductor is a diode. An electric circuit consisting of a battery connected across a resistor can be likened to a water circuit where water is pumped through pipes. The pump drives water through the pipes, causing a pressure difference across the ends of each pipe to drive the water through. Pipe X and pipe Y are in series because the amount of water that passes through both pipes per second is the same. Compare the narrow pipe X with the wide pipe Y. Which of the pipes have greater resistance to the flow rate of water? The resistance of the narrow pipe to the flow rate of water is greater than the resistance of the wide pipe. Similarly, in an electric circuit, resistance resists the flow of current, which is actually the flow of electrical charges. What is the difference between an insulator and a good conductor? An insulator does not conduct electricity because it has high resistance. A good conductor of electricity is said to have low resistance. To force water through the narrow pipe at the same flow rate as in the wide pipe, the narrow pipe needs to have a bigger pressure difference.
Similarly, increase in potential difference will increase the amount of current in the circuit.
Hence, the amount of current in a circuit does not only depend on the total resistance, but also on the potential difference in the circuit. Compare the resistance of both wires. Compare the slopes of both wires on the graph. Which wire has more resistance? Compare the slopes of both wires on the graph. Which wire has more resistance?